Welcome to Software Snack Bites. I'm your host, Shomik of Bold Start Ventures, where we partner with dev first and SaaS founders from the first line of code. Today, we're excited to have Phillip Carter on the show. Phillip is a principal product manager at Honeycomb and recently wrote the best blog post that I've read or seen yet on actually building and deploying an LLM-enabled product. I'm very particular with the language I use there because I think it's important that we talk about LLMs in the right way. And so in this episode, we're going to cover how to build products utilizing LLMs, the pros and cons, the challenges, and everything in between. So welcome to the show, Phillip.
Yeah, thanks for having me.
So let's start off with your background. How'd you end up at Honeycomb?
I initially started actually at Microsoft working in developer tools, fresh out of college, worked there for 6 years. Joined the .NET team as the .NET platform was replatforming onto being fully open source, fully cross-platform, and kind of like mission accomplished. After 6 years, we grew by like 3 million developers, and I took a step back. It was like, all right, what else is interesting in dev tools? So I got into observability for a number of different reasons, partly because I'd been used to very low-level stuff. So like building a developer experience around a compiler or this runtime feature is going to enable this thing that, several abstraction layers later, somebody is building something real on top of. And so what interested me about Honeycomb in particular is I didn't know a whole lot about observability at the time, but I knew like the general premise of it being that for anything other than trivial software systems, when you deploy it out into production, it's pretty much impossible to reproduce certain classes of bugs. And you need to have good instrumentation and good tools to be able to sort of analyze that data effectively. And that's just a whole wild world of like, depending on the kind of data and how it's stored, it kind of changes how you can analyze it. And I felt like their take was pretty much the one that made the most sense to me. And so I got a job there working as their developer experience PM. And yeah, I've been there about 2 years now. And through that, I've been a maintainer of the Open Telemetry project, which Honeycomb now is like pretty much 100% all in on. And then I guess I kind of pivoted last October. So the whole reason for my building an AI feature in the product actually didn't come from ChatGPT, because I was thinking about our querying interface and how we have this general problem that I imagine many developer tools have, which is you find product market fit with a group of people. And all right, cool. You have PMF. Yay. Except now you want to expand to other groups of people. And so many things that you built about that thing that got you product market fit don't really apply to a whole lot of other people. And so my take was, okay, well, we can't just totally destroy this thing because like we got PMF for a reason and there's tens of millions of ARR behind this thing. So it does work for what it does. But my general premise was, okay, people being effective with our product, there's no real right way to query your data in production. Everything is inherently probabilistic. And so I'm like, okay, well, machine learning is just the realm of probabilistic. Like you hope to build a system that uses machine learning that is like, 90% or so likely to be the right thing for somebody. And that I wrote a doc on that. And then it was like an internal document. And there were a variety of things where I'm like, hey, we could explore this, we could explore that, blah, blah, blah. And then ChatGPT came out the next week. And that pretty much changed everything.
Yeah. So maybe first let's cover, what Honeycomb does. And then I'd love to dive into Query Assistant in more detail as to exactly kind of what that feature enables for customers.
Yes. When I said sort of the premise behind Honeycomb is being able to analyze data in production. And so it's kind of like, okay, well, why do you do that? Well, there's a lot of complexity in the software world. Some of it is avoidable. Some of it is frankly not. Take even something like a monolithic application deployed in AWS somewhere. It's not actually a monolith. Chances are it's talking to a database. That's another service running somewhere. You may not be running that service. It may be AWS running it, but it's another service somewhere. You may talk to multiple databases. You may do authentication with like Auth0 or something, right? So, okay, there's another service. It's an external service, but you're still calling it. You still have a hard dependency on that thing. You have a load balancer sitting in front of your application probably. That's another service. And like, this is already a distributed system. Like it's not a big distributed system, but it's enough to where at these different pieces, something can go wrong. And you can't take all of AWS and Auth0 and whatever other external things you're calling, get it all onto your machine, load it up into a debugger in your IDE of choice and step through the code. It just doesn't work that way. And so what do you do now? Well, okay, you need to instrument and create telemetry from your application, gather that in a tool of some place and be able to analyze that data and be able to do interesting things with it. And so there's a whole lot of players in this space. Honeycomb is just one of them. And we all kind of offer a different flavor on things. I would say Honeycomb is part of a class of newer tools where our general philosophy is that you're not going to be able to create a dashboard for everything that can possibly go wrong. Everything is in this world of unknown unknowns. Developers change code all the time. Something goes wrong, and that may have happened like a month ago, and there's no way to predict how that's going to actually impact things. And that doesn't mean you shouldn't test. That doesn't mean you shouldn't try to monitor the things that you can actually monitor. But sometimes you just need a query engine where you can arbitrarily group by any dimension in your data at any point in time and be able to slice and dice hold one dimension to be true and be like, okay, what's different about all the other dimensions aside from one that I'm holding constant right now? It's very hard to do that with tools that are not Honeycomb, frankly. And you should really have this core analysis loop that's as fast as possible and as flexible as possible.
And so I imagine, of course, given what you just explained, like a lot of queries being run on Honeycomb. And so you looked at that, you're like, okay, hey, this is something that I would like to improve upon. I'd like to make sure we're making it easy as possible. So you write this doc saying, okay, here's the different ways that we could approach it. And then ChatGPT comes out, and were you just like, holy shit, like this is the moment, I just realized this is what could be used? Or what was the thought process once you saw that in terms of like, okay, now I want to experiment with LLMs?
So I guess I've been using LLMs for quite a bit. I have a friend on the Copilot team who got me like extremely early access because this is like, even pre-early access program, they wanted people to like smoke test this thing. And so I've been able to see a bit of that power. But then that did also kind of help inform this initial paper that I talked about that I wrote internally, where I was like, hey, there's all these applications of AI that could be done across our entire product that are still centered around just helping people. They have an objective in their head, and how do you translate that as easily as possible into a thing that's like, using the correct product nouns and like, clicking the right buttons or entering the right things into the text fields and that kind of stuff. And then, ChatGPT came out, and I think like everyone, I was pretty blown away by how easy it was to express what I want in plain English and get a very robust answer. And sometimes it wasn't correct, but you could kind of tune it a little bit. You can nudge it in the right direction. And so I knew that I wanted to do something with natural language querying. However, it was not economically feasible for us up until they made their pricing change, where they basically dropped the cost by using their API by 2 orders of magnitude. And so then I did some napkin math using like current querying volume that we have and said, okay, let's assume we use all possible tokens in every single request. And it worked out to like $100,000 a year, which could grow, but like that's like the cost of sponsoring a conference. Like,
yeah, there's no problem to that. One thing actually people have talked to me about with tokens in general is the fact that like you don't really know the word right? If you have lowercase the could be completely different tokens than if it's uppercase the, right?
Yeah.
And so when you talk about understanding using that tokens, because you're getting, rate limited on stuff and things like that, like, was that something that you had to take into account with Query Assistant? Like, how'd you determine, okay, we know this is the amount of stuff that will be able to pass through the context window to be able to leverage those tokens?
I spent a lot more time on tokens than I think I would like to admit. So the arc of this whole feature started off actually within ChatGPT. And so my goal in the first month it was just me. And I was like, okay, can I like on a 0-shot basis, like new chat session each time, just paste in something, just a big old blob of text, and then get it to emit a JSON blob that represents the specification of a Honeycomb query. And so like I went over into one of our internal data sets. I manually like copied over all the names of all the fields inside of the schema. And I had that in a block of text. And I had like an intro thing. And then I had another big old block of text, which was a big JSON blob that was like the specification and the rules for what works and what doesn't, and a list of domain knowledge tips and some examples and stuff. And, I iterated to the point to get there. But I ended up with an input that was about 3,500 tokens. And so that was quite a bit, because then I started doing the math on that when I looked at the rate limiting, and I'm like, oh, right. Okay, so we're not going to be able to handle very many people using this feature at once before we get hit with a rate limit. Oopsie, because you get 90,000 tokens per minute before they rate limit you for I don't remember what the period of time is, but at any rate, it's unavailable to you for your API key. And that's kind of shitty. We don't want to come out of the gates with a feature saying, hey, it's so easy to query, and then just have it blow up in front of people and they can't use it. That's kind of a disaster. So I had to spend a lot of time experimenting with how to reduce things and just finding, if I just delete this whole block of stuff, does that actually impact the results? Sometimes yes, sometimes no. And the counting of tokens as well is another challenge that we ran into, because there's several pieces to our prompt that we assemble that we then send. But I think the part that's the most critical is there's a block, which is a list of field names for a schema that you're querying. And so for most people, that whole thing can just fit right in there, because especially brand new users and like those who are on a free tier.
It's a fairly small amount. Yeah.
They just don't have that much data. And so, they have like maybe 50 unique fields, which is give or take like 150 to 250 tokens or something. Like it's not that big. But we have a lot of customers who have literally over 10,000 unique fields in their schema, and that's not going to fit inside of the context window, period. So we needed to get clever about what we include and what we don't include. And so we started getting into this world of being like, okay, what's the actual time range that people tend to query? And we looked in our BI data, and we find that if you include every single piece of a customer schema and how many queries did they run, it's a whole lot. But then you chop it off to only the ones that receive data in the past 60 days. And it's still basically the same number. And you're like, okay, cool. So we can ignore those. What if we make this over the past 7 days? And it's still pretty much the same number of queries that people, like very few people end up querying over very long time ranges. And very few of them actually need data that was active beyond a 7-day window. And so we picked 7 because in our UI, there's like a little drop down for choosing your time range. And that's one of sort of the UI options. And we pretty much capture most relevant data once we're at 7 days. However, there's a lot of like stale columns that exist in a schema, or at least they're stale because they're outside of 7 days. They still have data, basically, like the data is not aged out. But it turns out we can fit most customer stuff even just with that alone. And so the way that we went about trying to validate that and sort of knowing when a cutoff point is we experimented with a couple different options of counting tokens as we go. Because, you sort of make a cutoff point and sort of say, okay, there's like a part of the prompt that's static in size, that's X amount of tokens. There's a certain amount of tokens we want to reserve for input. There's a certain amount of tokens we want to reserve for output. Everything else is now what can fit inside of here. And because token counting can be a little bit challenging, and this 7-day cutoff thing is not going to be static each time from week to week, you're certainly going to have different data. You can't really know up front where you need to make that cutoff in somebody's schema. So we literally just sort by recency and go through it and then count as we go. It seems to overcount on average by about 5%, which we measure in production. So we sort of look at our estimated count and then what the actual count is. And that seems to be good enough.
How does that token counting actually even work? Like, first of all, one, can you go to OpenAI's documentation or something and they have everything listed out? Are you writing some sort of script where you're just running the prompt output and then saying, okay, this is what we would estimate? Like, I'm just curious, how do you even get to the point of like token counting?
So they use a pretty standard byte pair encoding algorithm that they do actually make available through open source, but only through Python. So we then have a port of that in Go, because our backend is written in Go, and produces the same results as what their thing is. And so then we use that. However, we do the counting as we go rather than counting the whole thing. And so that's why it ends up overcounting.
Got it. Okay. That makes sense. One thing you talked about is this few shot prompting terminology that you used. And, one of the things that you mentioned was like, hey, we have to have the input of what the schema is, the introduction on like, this is a schema, right? And this is something that you should be aware of. So what is few shot prompting? And I guess, is it an automated thing that you're doing where it's like, okay, because we've mapped the schema, now we're going to send that through to, OpenAI and then kind of start running it off of that? Or what exactly is happening mechanically behind the scenes?
Yeah. So for folks who are not familiar with prompt engineering, there's several different techniques. The general principle behind it is, you have a pre-trained model, and instead of having to train it on a bunch of stuff about like, hey, this is what, inputs and outputs should look like, and then, it acts based off of that training, you have no training. you just tell it effectively what your objective is, and you try to get it to shape its output to fit what your objective is. And there's a lot of different techniques for doing that. The most basic one that most people use is called zero-shot prompting, which is like you ask it a question, it gives you an answer. It tends to work pretty well for simple stuff, but when you have more complex tasks like this, especially if it's like a domain-specific task that like the model is not trained on Honeycomb queries, so it doesn't know anything about them. So how do you get it to know about those things? Well, you do that through a variety of different prompting techniques. And so few-shot prompting is a way of you sort of bundle up your context of what information is relevant for it to know. And it's basically giving it examples, but you're sort of simulating a conversation where you're saying input is, I care about slow requests. Output is what the output should look like in this fake interaction that you have. And you do that a few times, and it's able to pick up on how it should generally respond to things. And there's within few-shot prompting, there's a variety of other, like you can combine this with a bunch of other different techniques. You can try to generate as many examples as you can, but then if you generate too many, it can also sort of overfit on like one particular style. And so you need to sort of figure out what the right balance of these examples are. But it's basically like simulating interactions with the large language model, and it reads it, and it's almost like sort of tricking it into thinking that this is how it's behaving. And then you have your final thing, which is the user input. And then you sort of leave a spot for it to be like, and do it. And then it tends to produce far more accurate results if you do this than if you just try in one single go, bundle up as much information and rules as possible, and then say, okay, give me something. It's like a show rather than tell kind of principle.
But each time, let's say I am using Query Assistant, right? So I go in, I'm like, okay, I want to figure out slow requests on this time period or whatever, right? Help me out with that. I pass that through. Do you have to then send prompts each and every time? Or is it to the point where, okay, hey, we've already trained up and done the inference to a certain amount of viability that now we don't have to pass through that every single time?
It's every single time we actually send that whole block of examples as a part of the prompt. And so the challenge that we have there within the product is selecting what the examples should be. Because if you're using OpenTelemetry, there is actually a pretty standard way that things are named. There's http.request_method that's the request method, and that's the standard that it follows. And so that you can have a pretty good likelihood that that's what it's actually going to be in somebody's data if they're using OpenTelemetry. If they're not using OpenTelemetry, all bets are not really off because of two factors. Number one, the names that OpenTelemetry picks for things are pretty damn reasonable names that most people tend to use anyways. Like they might have a dash instead of an underscore or a dot instead of an underscore or something like that. But they tend to use pretty much the same letters to represent a name of something that tends to matter. And the large language models are pretty good at being able to pick up similarities between things. If you have an example that uses request.http_method, and then somebody's field for the same thing is request.method, it's actually able to pick up really, really easily that request.method is the thing that you actually want. And the example here, oh, that was just a different name, but you sort of force it to say, yeah, you're going to use the columns that came beforehand, and you can do that. Now, there's other things that we do where we do have a part of our product that we call suggested queries, where we basically have this bank of queries that you can just click on and run, and they're sort of loaded up statically based off of what your schema is. And for the vast majority of people, there's about 5 or so that are pretty much always available, and we just load those into our prompt. Those are also customizable. And so it's a benefit to larger customers who have a very larger complex domain. And then what they can do is they can set up these suggested queries to fit what they should actually be generally querying for this given data set. And then that helps the LLM as well, because now it sort of understands based off of the name of this thing and the shape of the query, like this is kind of the general way that you should be answering these sorts of questions. And then as a final thing also, for new users, there tends to be a pretty fixed set of questions that they ask initially up front. And I think part of what we get away with, I think if this was our only interface for being able to query data, I think it would be pretty bad. But what we're seeing is it's acting as a phenomenal on-ramp for people who are not familiar with our querying interface. And it teaches them that they can group by multiple columns, that they can filter by multiple things, that they can visualize multiple things at the same time. And after about 3 or 4 times that they use stuff, they actually effectively graduate off of Query Assistant and just use the Query Builder normally. And we found that if we look at new users and the folks who come into the product and do not use Query Assistant, they on average activate, I think, at a 13% rate or something like that over the course of a month. Whereas those who do use Query Assistant do it at a 40% rate or something. Like it's a massive difference, because once you know that you can do more complex queries in our UI, then it opens up so much more of the product. And they just sort of go, okay, well, I know how to use this thing, so I don't really need to use Query Assistant anymore. And so I think we were able through, this is kind of by design, but I guess also kind of, you never really know how something's going to work until you actually get it out there. But we find that there's sort of this natural graduation point where like it might fall over if you try to ask these much more intricate questions. But by the time you're doing that, you know how to use the product already, and it's kind of done its job.
Yeah. One thing you just described there, which I almost will ask you to wax a little bit theoretical here, but in terms of usage of LLMs, right? We're talking a lot about using natural language. It's great for search, it's great for UI, UX, right? But what you just described is almost like, hey, I just created a better onboarding onto our product, right? And I've increased the conversion to that wow moment a lot quicker and helping the customers get a lot more value in that time period. Is that kind of how you view LLMs generally, as, hey, right now it's a great UX driver and enabler versus some sort of new paradigm or new way to architect a solution?
I think right now, yeah. So at least certainly through the lens of Query Assistant, the two things that we've seen success with is, yes, as an onboarding ramp for people who are newer, and as a way to, like, you already know what you want to ask, but it's actually just easier to express it in the English language than it is to click around in our UI 15 times. So as a shortcut to the UI, it can also be pretty beneficial, but that's where it can be more hit or miss, because you can often have much more intricate things that LLMs typically fall over with. And, maybe if GPT-4 latency gets better, that could sort of get solved. I don't know. But right now, we also, like many products, we have a latency requirement where you can't spend a minute generating something when you're in the middle of an incident or something. You need to be able to see what's going on right now. So to wax philosophical a little bit, I guess, I think there's a couple points. I think the first is you can't hide your product efficiencies with LLMs. Unless you are OpenAI or Anthropic, like, the LLM is not a product. If you're building a chat app with retrieval, that's just going to be in ChatGPT within a year. So I don't know, try to make as much money as you can, but like, there's nothing differentiating about that. Insert, chat app with whatever pretty basic thing that you can sort of cobble together with enhancements that ChatGPT doesn't have. I'm just going to assume that that's going to exist by these platform providers. And so what can you build that is differentiating? It's still just product development. You just have this super engine that can take natural language, at this point at least, and also images, depending on what you're using, and a couple of other inputs, and produce useful stuff. I view it as kind of no different than a database in that sense, right? When databases hit the scene in 1985 or something like that, SQL databases, all of a sudden now applications could store data from users, and they're like, what? Oh my God, we could analyze that data, do all kinds of... I feel like it's a similar kind of moment, but SQL databases they weren't applications. They enabled entirely new kinds of capabilities that you can do before. I think LLMs could potentially do that. I think onboarding is the best use case for them right now, because typically onboarding requires somebody to do something less complicated. And humans are pretty damn good at doing stuff once they know the general principles behind how they should do it. And if you can get them to that point, you don't need to spend forever trying to get an LLM to be awesome for complex use cases. You can just actually make the rest of the product work well for that. And that might actually be a general pattern that you follow, where you sort of find product market fit for a slice of the market that needs something that's more advanced in nature. And then you figure out a way with LLMs to bring people up to speed with that. I'm a little skeptical right now of the agent use cases that people are doing. I saw there was lots of hype with AutoGPT and a couple of others. And there's maybe at some point in the future, there probably could be some agent use cases where, like, you just give it a task or a list of tasks and it breaks it up into however many subtasks it needs to do and just sort of executes all of those things. The bit that I've played with it, we're not there yet. AutoGPT and friends tend to fall apart pretty quickly unless you have an extremely, extremely rigid set of allowable inputs and outputs. And maybe that's something that, some of these models, especially with fine tuning, will sort of get to the point where they can really only do inputs and outputs in extremely confined ways. But if you can sort of apply those constraints to whatever you need to do, then maybe it'll be acceptable at doing that. Then, you could potentially imagine an economy of applications that have, the ability to take a more general task and execute on it however you need. I still don't think that removes the need to have good UX in the first place for your product. It needs to be able to do something good, but I don't know, sometimes I find that a lot of these things, I need to use my brain to be able to get to the point where I can do the boring thing. And it tends to not be that helpful for me because, at every point where I feel like an LLM could speed this up, I actually need to think a little bit. And then by the time I have like this fully formed thought in my head about what I need to accomplish, it's usually pretty damn easy to accomplish it. There's some cases where that's not true. Like if I know the shape of the data that I need to pull from something, and then I can sort of get it to the point where, I iterate with an agent and it sort of shows me what it did and I say yes or no and kind of gets there. But it's also really not that different from just using like a program with an API that does the same thing that I just run as a Python script or something. And so like the time I'm saving is not that much. And so that's where I have a lot more skepticism right now. And I think a lot of people are also running into similar roadblocks. We're not seeing applications, as far as I can tell, I don't think we're seeing applications take the world by storm, where now there's like a completely different way that Salesforce is no more. All the sales folks are like using these agents now. Like, no, that's totally not true right now. Maybe I'll eat my shoe in a year and we'll see what happens. But I think if people are building these, I think they're also running into a lot of roadblocks right now. And the other piece to that is there was a recent speculation on Hacker News that got a shitload of comments about GPT-4. And people were like, hey, has OpenAI nerfed GPT-4? And like my belief was like, no, I don't think they nerfed anything. I think like the magic wore off because you've been trying to get it do much more complicated stuff than when you were initially using it. And it's just kind of falling apart right now for those tasks because turns out what you're trying to do is really, really hard.
Yeah, that makes sense. I want to go to actually talk a little bit about like your advice for other people that are looking to build with LLMs. And so say you're a startup founder, right? You probably have an idea for a product that you could build with an LLM. Now, what's interesting is what we talked about with Query Assistant, you were not necessarily saying, hey, I'm going to use LLMs to do this, right? It was like almost the idea for Query Assistant came first and then, or maybe not Query Assistant in its instantiation right now, but the idea that, hey, this is something I want to improve came first. And then you were like, LLMs are a good potential use case and a way to solve that. For the founders that are just saying, the boards, the investors, everybody are telling them, hey, where's your AI story, right? And all this sort of stuff. And so they're just like, well, shit, we got to ship an LLM feature. How should they approach that? And I guess my question to you would be like, do you think it's worth it for teams to still just ship some sort of LLM enabled thing just to learn how the process works so they can be ready as the technology starts to improve?
So that's a good question. I mean, I'm biased since I'm a product manager, but at the end of the day, people are struggling to do a task. How do you solve that problem for them? What's the most effective way to do it? And if the most effective way to do it is to put a button on a screen, then just put the button on the screen. Like it's pretty straightforward there. I guess it can be challenging to sort of figure out where an LLM can be helpful. I don't think it's bad to do sort of what you mentioned, like experiment or sort of try it out and see what can happen. But you shouldn't bet the farm on this stuff yet because, whether you run truly up into the technical limitations or like you just don't have enough experience or understanding of how to prompt effectively, you're going to run into problems with it. And so it still comes down to problem solving. And I think like the general principle that I would think for that is if the solution to a problem for someone is inherently probabilistic, there's a task that somebody needs to do within your product, and there's zero way to know upfront what the right way to approach solving that task is. Machine learning is a good way to do that. That doesn't necessarily mean LLMs, but it's probably going to involve LLMs because if you're doing machine learning for the first time, you probably don't have an ML team. You probably don't know how to set up all this kind of stuff. And LLMs allow a product manager like myself to actually ship product without, a whole team of people to do stuff. Then yeah, absolutely go for it. but it's probably not going to be the most effective thing that you can do. Like, I mean, we have an example of this at Honeycomb where throughout the entire product, we're focusing on product activation for new users, whether they're brand new to the product or whether they are on a team that an existing customer is like trying to expand to that team or something like that. One of our features is called triggers. It's a way that you can get an alert based off of the result of a query constrained to, a particular set of parameters that you want to identify. So, your database runs out of memory. You should probably get a notification about that. So that's one way that you can do that. Part of trigger activation that we struggle with is people were just not creating triggers, and we would interview them and they'd be, well, I want to get notified about this stuff. Well, that's what triggers are for. They're like, well, how do I do it? And so the most effective solution was actually literally, I said, put a button on a screen. It was literally put a button on a screen. Once you have run a query, a button appears up above of it called Make Trigger. And we found it was like a 70% jump in trigger creation by people. Like, we could have used AI, I guess. So, hey, I want to get notified on X. What do I do? There could have been maybe a chat interface or something that tells you to use triggers, and maybe that would have been effective as well. But it was way cheaper to put a button on there. And the jump in usage that we got that we were looking for, because the people who wanted to do the task, was massive. And it was an hour of engineering work to like build it and run the CI, deploy it. So that's one small slice of it. But I view it as a tool in my tool belt. I view it as something that's effective for things that are inherently probabilistic. But I don't view it as something that you should necessarily have a strategy for. I don't believe in AI strategies. I believe in product strategies where AI can help you. But that's my take.
Yeah, I love that answer. And I think that's something that I agree with sincerely as well. But one thing you mentioned in the blog post was you had a best efforts kind of output or result, right? And I just want to understand what exactly best efforts means, because does that mean that is there something written there that says, hey, user, guess what? Again, this is what we're trying to help you with, but you can't trust this answer because you should still read our documentation or something like that. What exactly does best efforts mean?
So I think it's helpful to think about what people input to this, which is also part of the reason why we enabled it for everyone and shipped just immediately for people. Is first of all, there's people who paste in, or I shouldn't say, people who type out like exactly what they need. And a best effort result for that, it tends to be pretty much entirely accurate. If you know what it is you're querying, you can express that pretty simply in English language. And so long as it's something that is expressible within our querying engine, it can do that. Now, there's a little bit of nuance to that. What we shipped initially, it actually wouldn't always do that. And so we did a lot of tweaks to our prompts, and then also a lot of output corrections where we look at the shape of what comes back. And then we can say, oh, there's a clause in this spot, but that's actually incorrect because there needs to be an equivalent clause in another spot. And so we can actually just put that one in there. So even though the LLM wasn't quite right, it doesn't matter because we can sort of make it seem like it was. That's one aspect of best effort. But we have a wide variety of inputs that people ask. We have this stream in our Slack where we look at what people just sort of input, and you can dig into that specific thing. People paste in like IDs for traces, just literally just the ID, and then hit enter. And you're okay, like this is a GUID. What on earth could this be? So that's really what I mean by best effort, is what we think is an ambiguous input. What is the best possible thing that we can give to someone? Because the general principle that we have with this is that it's better to show something than to show nothing. And sometimes you can't show anything, especially if somebody is asking something that's pure nonsense. But we try to be as opportunistic about creating a query as possible. There's a handful of visualization operators and a handful of things that people tend to care about that you can actually kind of plant in there, and it tends to be okay. So we have an operator called account. It counts stuff. It's usually pretty helpful. We also have an operator called a heat map. It shows a distribution of things visually, usually pretty helpful as well. Average is, anytime it seems like somebody's asking for a thing called average, it always puts average in there somewhere. May not be perfect, but it's probably better than nothing. And especially if it can show that you can visualize multiple things at the same time, or you can group by multiple things at the same time. Like if you say latency, if we see that there is a standard HTTP outputs or attributes, I guess, we show a heat map on duration in milliseconds. We show usually average in duration in milliseconds or max in duration in milliseconds. Does this answer the question of latency? Maybe not, because maybe you actually did have something very specific in mind, but it shows you something, and it shows you that, hey, you can group by multiple things.
Yeah.
And so like, oh, I can just click in this box and I'm going to group by the thing I actually care about, and I'm going to delete the other two. And it tends to be way better than trying to be as helpful as possible there. Instead of trying to be as accurate as possible, we're trying to be, I guess, as helpful as possible. And to the point that Query Assistant allows you to recognize that you can interact with our querying interface the way that you can, it's really easy for someone to just sort of manually correct it. And then it becomes sort of like a, hey, this scaffold is 75% of what I care about. I'll just do the remaining 25% myself.
I think that goes back to the on-ramp concept that we were talking about earlier. So that makes perfect sense. One thing that I'm also kind of curious about is database access is something that you currently don't have Query Assistant tied to. And so when you're doing these visualizations and things that you're doing it, I'm assuming what's happening is Query Assistant's helping to actually build that query, and then there's a separate execution step that is actually then going through the typical Honeycomb flow to then query the database through those systems. Is that correct? Where it's like there's that separation between that. And from that perspective, would there ever be a chance that you would connect it directly to the database, even if it was just you could restrict the access or something somehow and say, like, we're only going to use this tiny columns or something that doesn't have any PII or anything in it? Do you ever envision a world like that?
So yes, first of all, you're correct. It's a multi-stage process. And so the way that Honeycomb actually is internally is we have our querying system, then we have our main database. Basically, when you load up our UI, the main database is called and it fetches all the information, like this is the schema that you're querying against for this data set, and a bunch of other stuff too. When you actually query, it doesn't touch the main database at that point anymore, even when you're manually using the product. It just uses our querying engine, which is in effect its own kind of database, but it's a special one that we built that data ages out after 60 days. The whole thing runs on just Lambda and S3. It's trivially parallelizable, so we can spin up to like 30K lambdas for a given query if we need to, which one of our customers has done to us before. Fun COGS problem. But that does mean like this was easy from a security standpoint for us to embed a large language model, because like at 0 point does this actually interact with our main database, which is a multi-tenant system. And so thus there's no point at which somebody could do something like exfiltrate customer data or something along those lines, which is kind of a nightmare scenario for a lot of people.
So you're caching based on some sort of time limit or something like that, or?
It is cached in a sense. So basically, like every 10 minutes, there's sort of a poll that says like, hey, is there any changes to this schema? And if there is, we're just going to pull those changes out. And in practice, that tends to pretty much capture everything within our product that people care about. So yeah, because we're not actually in a position where touching customer data with this LLM in some way, it's pretty safe for us to deploy, crossing my fingers here. The only time that something actually makes it into the database is when we have a valid query that comes out. And so like there's a bunch of query validation rules that run as a part of executing in the querying engine. And so once it executes and it gets a query result, that stuff itself gets saved back to our main database and associated with like, hey, it's, this is the team ID, this is the data set ID, this is, a bunch of other info. Saved as what's called a query run. But at that point, like this is completely disconnected from the LLM. Additionally, because the LLM there's no chat interface, there's no way to sort of like very quickly iterate and sort of see what its outputs are and trick it into doing something that it shouldn't be doing. And then like, it's really annoying to do that with our UI if that's your goal. And so, that is one of the principles of computer security, is that if you make something annoying to do, like the likelihood that somebody's going to be really, really want to do it is a lot lower, because there's probably easier targets out there. There is a future, though, where we are going to want to do something like this. So another part of our product is called service level objectives, or SLOs, and it allows you to define a threshold for behavior like error rates. Because you get one error, you shouldn't necessarily page somebody at 2 a.m, depending on the error, especially if it's like a UI error or something like user can refresh the page. But if you get enough of them, you have this budget that you set up that's going to burn down. And eventually you should progressively start notifying people and be like, yes, there's an issue here. You should go fix that. The challenge that people have is they have a business objective in mind, like the UI should not have errors, or there shouldn't be latency in, such and such service. But they really struggle to set up what an effective service level objective is for what they're trying to do. And the best bank for this kind of stuff is existing service level objectives that people have. And so similar to a principle that like Amazon has, where, you see customers also bought this, you could imagine something like, based off of your shape of data, people with similar shapes tend to do this. And that is going to be trickier because we're going to need to figure out a way to try to be as safe as possible because, as you're probably aware, with prompt injection, there's really no way to solve it. And it's really just about keeping things as isolated as you can right now. And that's going to be hard. But like, this is a really valuable problem for us to solve for our customers. And so it is something that we're going to be having to look into. And so I'm kind of terrified at the idea of how I figure out a way to not, have the LLM talk directly to the database and thus open us up for data leaks. But
Yeah.
We'll see what happens.
I think we're all worried about that too, but hopefully there'll be things that improve upon it. But we're getting to some of our final questions here. But one thing I want to ask before we get into the last two questions is, and I'm going to read this specifically, but basically you were saying that you're talking about embeddings and praying to the dot product gods, and a bunch of people who read it were like, "Oh my God, that's hilarious." I am sad to say that completely flew over my head, and I have no clue what that means. But so maybe if you could dumb it down. Why are embeddings the potential solution to this context window problem that we talked about earlier and solving that?
So you have a whole bunch of context. You got to fit in a context window. It's not going to fit. You could truncate with some of the stuff that we're doing today, but then that's lossy because somebody might be asking about something that like the part that you truncated actually has what they need. So embeddings, or vector embeddings as they're called, it's a technology that's been around for quite a long time. There's tons and tons of research behind this for the past decade. It's a very, very fast machine learning model where you send it text and it produces a numeric representation of that text in n-dimensional space, vector space. And basically the idea is you can then run math operations on pieces of those vectors and sort of see how close they are mathematically based off of certain kinds of mathematical properties. And so these are called distance functions. And these distance functions it's matrix math. So it uses like dot products and things like that. And different distance functions are better for different kinds of things that you care about. And so you want to sort of pick the right distance function, in this case for natural language processing and choosing how relevant one word is to another word. So in this case, a string of text that represents somebody's natural language input saying that what they want to query for. What are the most relevant names of columns in a schema that map to what they asked about? That's sort of the problem that we're trying to solve. And so there's a specific distance function called cosine similarity that on average tends to give you the best results. And at least for our problem, that might not necessarily be true for other problems. And so that's why you sort of pick between these different functions. And cosine similarity does a dot product as a part of it. And you get back, you basically say, hey, I want like the top 50 most relevant things that map to like what this input is.
Hence the prayers.
Yeah. And I say like you're pairing to the dot product gods because like any statistical operation, like it could still go wrong. And then, oopsie, you've elided something that, so, let's say you pick the top 50 when you could have fit like the top 250. Maybe that top 250 would have included the thing that was relevant, but you've actually truncated it even more. Now, in practice, it actually doesn't work out that way usually. And so it's mostly fine. So that's why we're going down that route. There are other challenges that brings, though, because let's say somebody wants to create a query. They say, show me latency by blah, 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 blah. Okay. But then they want to modify that in natural language as well. And so typically when somebody wants to modify something that exists, they're like implicitly assuming that that thing that exists is a part of what they're trying to do. They don't say, hey, in this query where I said blah, 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 I now want you to do this other thing. They just say, do the other thing. And so you need to be like, okay, I need to also include the existing thing as context in addition to what I'm sort of searching in my vector space and package up that whole thing. And so we have one type of problem. There's lots of other types of problems that you get into with embeddings where you need to sort of figure out how you organize and slice your relevant documents and all that kind of stuff. But it's cool.
Well, I smell and hope that's the case, that you've got another, embeddings blog post brewing for the Honeycomb blog. So hopefully that's coming out because I would love to read it. But penultimate question is basically Rob Bailey, who's the founder of Backbone AI, had a question for you. And he basically asked, what are your 2 to 3 guiding UX principles for LLM features? And he mentioned that in relation to things like, should you be thinking about, or should you be weighting more like initial tuning or result scoring to make sure that the right output is going on, or result acceptance, things like that?
I think it's kind of hard to answer it because the answer is going to depend on what your ultimate product goals are. So like in Honeycomb's case, speed performance is part of our UX because people want fast queries. In fact, that's actually one of the main pain points for like people why come to us. Why people come to us in the first place is because we have a fast querying engine and a lot of people don't. And they're like, I'm sick and tired of assembling my query, clicking run, and then waiting a minute and losing context in my brain about what's happening. So that puts a hard constraint on a lot of what you can do with LLMs, because if you make latency one of your top requirements, now you can't do all these different chaining techniques where you could potentially produce a better answer, but it would take like a whole minute of LLM compute to sort of get what you want. I almost think of it as like compile time versus runtime constraints. Like if your product has a compile time constraint, then you can spend more time up front and you can start going down these techniques of being more creative about how you use LLMs. And if it's okay for the user that they wait a little bit, but then they get something really awesome at the end, then go for that. But a lot of products have what I'll call runtime constraints, where somebody is in the middle of a task that they need to get done, and the LLM is just a part of helping solve that task. So what are some UX elements to help with that? Well, obviously you want a natural language input, or if you're doing something with images, you want to be able to wait to send an image in there. Copy paste is great. Upload from computer is great, that kind of stuff. I would say the other thing is there needs to be suggestions. We found really early on with new users that a blank text box, people still get intimidated by. If you have little bubbles that you can click, or I don't know, something, we call them bubbles or pills, like a thing to click that demonstrates how you use this thing to give them a little bit of a hint of what they can ask, it really helps. If you know how like some text box have that gray text in the center that has example of what you could ask, put that in there. Another great example of UX for this is GitHub Copilot for Docs. It's a public preview, so you still have to sign up for it, but it's a wonderful thing that they did where they index entire document corpuses like tech docs, like MDN or the React docs. And it's basically a text box where you ask it a question. But first of all, there are examples of what you can ask. There's also a slider of what you want the output to be. There's also a slider how verbose and creative versus how just succinct and straight to the point you want something to be. And that also influences how many code samples you'll get. And then there's also a slider for I'm a beginner and I know nothing, all the way up to I'm an expert in this material. And it also influences what the outputs are like. And that tends to be really, really helpful, because if you give users a way to very, in a light way, just sort of tune how they want this thing to behave for them, they're going to be much more likely to engage than if you just throw a chat UI in there and say, go. So I don't know, that's kind of roughly my thought process.
Well, it's funny because what you just mentioned is not that different than the normal stuff that you would suggest for someone for, UI, UX things. So I think that makes a ton of sense. The last question I have for you is we spent a ton of time, and obviously the blog post was about the challenges of building with LLMs, right? But at the same time, you shipped Query Assistant and you saw a conversion and people are using it more. And it's very exciting from that perspective. So what got you super excited about LLMs through this process of building Query Assistant?
I think the thing that probably got me the most excited was once we had something that looked like it was kind of real. It was still assembled with duct tape and glue behind the scenes. This is internal only kind of stuff. Our solutions architect team, this is our technical sales folks who help people start to use the product and do a bunch of different stuff. We showed it to them and their eyes just lit up and they were like, holy crap, this is what everybody in our sales pipeline struggles with when they're starting, is how do I start using this thing? And so that day they're flagging this team right now. And then we did. And then one of our director of solutions architects came back and he said, that was the coolest thing. They were like, how do I ask this question? And I'm, well, let's pull up this Query Assistant thing that we're working on. And I just typed the thing out and I hit it and it gave me the goddamn query. and I was, wow. And he's, you need to ship this right now. And it was great because, first of all, it's a validation that you're building something that is useful to other people in the company. But this was literally the problem that they struggle with. And this was a direct solution to that. And so even if this was only useful in our sales pipeline, it would have been something that we shipped. Now it has a whole bunch of other stuff that we're seeing from new users who are self-serve with the product, which is also awesome. But I think that was probably the biggest positive moment for me, where it was like, yes, there is immense value in what we're building here.
On that note, I would just like to say thank you so much for everything that you've talked about here. And thank you for your writing. I look forward to reading future posts that you guys ship. And, frankly, we'll probably have to do a V2 of this because I think everything is moving so quickly that, I imagine in 3 to 6 months, you'll have a completely new set of challenges, but also opportunistic things and exciting things that are enabled through this. But Phillip, where can people reach you if they'd like to get in touch?
Yeah, so several different places. I have a website that I infrequently blog on called philipcarter.dev. I am on Twitter as well at _CarterMP. Little differences there. Somebody stole Philip Carter, so I couldn't use that one. If you search for Philip Carter on LinkedIn, I think I'll probably show up in like the top 5-10 results. There's this one lawyer who works for Salesforce who is like kind of a big deal, and so I think he's going to be the top result, but maybe I'll be number 2. That's pretty much it as well. I also have my email, phillip@honeycomb.io. You can always reach out at any time to ask me questions about this stuff. And yeah, I'm available to chat about this a lot.
Thank you so much for doing this. I think it demystified a lot of stuff for teams that are frankly looking at trying to implement this right now, from growth stage companies with 2,000 plus employees all the way down to the 10 to 20 people teams that are looking for this. And so this was refreshing, super useful, and we just really appreciate it. So thanks, Phillip, for your time. And this was a great discussion.
Absolutely. Thanks for having me.